A curve C is equation y equals 9 over 2x minus 5 plus 2x minus 5. Then part A says, find the coordinates of the two stationary points. Find the coordinates of the two stationary points. And we know that at stationary point, the gradient is 0, so dy dx is 0. So we're going to differentiate this to get its dy dx, right? So we're going to find dy dx of 9 2x minus 5 to the power minus 1 plus 2x minus 5. This is the same as this, right? So dy dx will be minus 1 times this 9, right? Then we multiply by the derivative of the bracket, which is 2, open bracket, 2x minus 5, subtract 1 from the power. Then for this we'll get 2. So this will give us minus 18 over 2x minus 5 to the power 2 plus 2. So this is the expression for our gradient. And we know at the two stationary points, this is equals to 0, right? So we can say 18 over 2x minus 5 squared plus 2 equals 0, right? That will be 2 equals 18 plus over 2x minus 5 squared. And cross multiplying this, we get 2x minus 5 squared equals 18. So we're just going to expand this, right? Then you multiply the whole expansion by 2. So it will be 2 square bracket 2x times 2x, it will be 4x squared minus 20x plus 25, right? That's what we get after expanding this, equals 18, right? Now multiplying everything by 2, we get 8x squared minus 40x plus 50, and taking this to the other side, minus 18 equals 0, right? And this comes down to 8x minus 40x plus 32. So it will be 8, let me just use a different color, 8x squared minus 40x plus 32 equals 0. And for this, we divide everything by 8. So this will be x squared minus 5x plus 4 equals 0. Then we use the quadratic formula, x equals 5 plus or minus 25 minus 4ac over 2, right? And punching this in our calculators, we get x equals 4 or 1, right? So for us to get the coordinates, we're going to substitute these two values into the original equation. So first, if we substitute 4, right, when x equals 4, y equals something. When x is equals 1, then y should be something. So we're going to substitute 4 and 1 into this original equation right here. So substituting 4, we get our y to be 6, and substituting 1, we get our y to be minus 6, right? So the coordinates will be 4, 6, and 1 minus 6, right? Then we move on to part B, which says find the second derivative and hence determine the nature of each stationary point. Right? We're being asked to find the second derivative. We know the first derivative is minus 18 over 2x minus 5 squared, 2x minus 5 squared plus 2, right? Which we can rewrite as 18 2x minus 5 to the power minus 2 plus 2, right? So the second derivative will now be minus 18 multiplied by this power minus 2 multiplied by the derivative of the bracket, which is 2. Then we bring down this bracket, subtract 1 from this power to get minus 3, right? Then that should give us 18 times 2, 36 times 2, 72 over 2x minus 5 cubed, right? And with this now, this is our d squared y over dx squared, the second derivative, right? We are now going to substitute x equals 4 and x equals to 1 to see whether we have to determine the nature of each stationary point, right? So substituting 4, we get 2 and 2/3 for this, right? And we see that this is greater than 0, so that means it's a minimum. If the second derivative is greater than 0, it means it's a minimum at that x value. And if we substitute 1, we get minus 2 and 2/3, which is obviously less than 0. And so if the second derivative is less than 0, we get a maximum. So now we know that our graph has a minimum at 4, 6, a minimum at 4, 6, and a maximum at 1 minus 6, right? Now on to C, which says the curve C is transformed to the curve C1 using a translation of minus 3, 7, followed by reflection in the x-axis. So we have a translation first, which is being followed by a reflection in the x-axis. And the first question says, state the coordinates of the maximum point of C1. Maximum point of C1. So if our C was like this, for example, the original curve, we know it had a maximum and a minimum. So let's say it was something like this, right? A minimum and a maximum, right? Then this translation was applied. It will still look pretty much the same as this one. Then followed by a reflection in the x-axis. It will be reflected using this line as a mirror line, the x-axis. So it will look something like this, right? And you can see that the minimum of this would be the maximum of the other curve, and the maximum would be the minimum, right? So since we know that the original curve is a maximum at 1 minus 6 and a minimum at 4, 6, if I'm not mistaken, yes, it's minimum at 4, 6 and maximum at, let me write that down, it's, it's minimum at 4, 6 and maximum at 1 minus 6. So like I said, the minimum will be the maximum for the reflected curve, right? So we're going to be dealing with 4, 6, right? And we're told that we're going to transform it using translation first followed by reflection. So we're going to transform this point using these transformations here, right? So for the x, we're going to say 4 minus 3. Then for the y, we're going to add 7, 6 plus 7, right? And after that translation, we're going to have 1 and 13, right? So for us to reflect this point in the x direction, let's try and picture this. If we have our y and our x, then the point 1, 13 like this. If we reflect it in the x, right? If we were to reflect it in the x, we will get a point which is here, which has the same x value, 1, but the y will be negative, minus 13, right? So the final point will be 1 minus 13, right? This will be the maximum for the new curve C1. And for the second part of this question, it's saying find the equation C1 in the form y equals a over bx plus c plus dx plus e, where a, b, c, d, and e are integers. Right? A, b, c, d, and e are just numbers. And so for this, we're going to try and use the original equation. Y equals 9 over 2x minus 5 plus 2x minus 5. And we know we're going to apply the transformations minus 3, 7, and the reflection in the x-axis, right? So we're going to apply this transformation first, right? Minus 3, right? So applying this transformation, we get y equals 9 over 2x. So if it's minus 3 on the x, writing it in the equation, we multiply it by minus 1, so it will be plus 3 minus 5, right? Then plus 2, we do the same, our x plus 3, then minus 5, right? So if we're writing the transformation on an x value in the equation, we multiply it by minus 1, right? So applying that transformation of minus 3 in the x direction, we get this, right? And applying the second one on the y, which is 7, this will be y equals 9 over 2x, 2 bracket x plus 3 minus 5 plus 2x plus 3 minus 5 plus 7. So for y, we just add, no need to multiply by minus 1, right? So let's simplify this before we apply the reflection in the x-axis. So this will be y equals 9 over 2x plus 6 minus 5, that's 1, plus 2x plus 6 minus 5, that's 1, plus 7, that will give us 8, right? And for the reflection in the x-axis, it's multiplying the whole thing by minus 1, right? That's how we reflect a graph in the x-axis. Multiply the whole thing by minus 1. So this will be y equals minus 9 over 2x plus 1 minus 2x minus 8, right? And that will be the answer for this question, right?